exponent laws that you covered in grade 9. Just to refresh your memory, exponents are the repeated multiplication. So if I want to multiply a number, say, 3 times, instead of writing, let's say, 2 times 2 times 2, 3 times, I'm going to say 2 exponent 3. Okay? So exponents is another name for repeated multiplication. Now, with exponents, there are a couple of rules that you have to memorize. Now, before I start with the laws here, exponents are written as A exponent B. We call A to be the base and B to be the exponent, and the whole thing is called the power. So A exponent B is called the power. A is called the base, and B is called the exponent. Let's go through the exponent laws. The first law, very simple, is called the zero exponent rule. What it means is that any number exponent 0 is equal to 1. As long as the base, which is A, is not equal to 0. That's a no-no. You can't have the base equal to 0. Any other number, exponent 0, is going to give you 1. This means that 10 exponent 0 is the same as negative 10,000 exponent 0 is equal to A exponent 0. All of them, they give you 1, no matter what. That's rule number 1. Now, rule number 2, very important. When you are multiplying powers, if the bases are the same, then you add the exponents. So as long as the bases are the same, you just add the exponents together. This means that if I have something like 2 exponent 3 times 2 exponent 4, the answer is 2 exponent 3 plus 4, which is 2 exponent 7. So the next rule is the division one. If you are dividing 2 powers with the same base, you subtract the exponents. So this means that if I give you something like 3 exponent 4 divided by 3 exponent 2, you say the bases are the same, which is 3, so I'm going to subtract the exponents, which is 4 minus 2, which is 3 exponent 2. So multiplication, you add; division, you subtract. The next one is called power of a power rule. If I have a base to an exponent b, the whole thing to another exponent, you just multiply the exponents. So a exponent b exponent c is a exponent b times c. Example, if I have 4 exponent 2, the whole thing to exponent 3, then it's going to be 4 exponent 2 times 3, which is 4 exponent 6. Again, as long as a is not equal to 0. This is called the power of a power rule. So far, you know 4 rules right now, which you remember from grade 9. So the last rule is negative exponent rule. Now this says that any base to a negative exponent is the same base flipped, but this time to the opposite exponent. This means that a exponent negative x is the same as 1 over a, flip the base, but this time the exponent becomes positive. So, to give you one example, I can write 3 exponent negative 4 is the same as 1 over, flip the base, which is 3, and the whole thing is going to be opposite exponent, the sign. Negative 4 becomes positive 4. Now, one thing you have to remember, this is not just for negative exponent, meaning if I give you, let's say this time 3 exponent 4, and I ask you to write it in negative exponent, you do exactly the same thing. You take the base, flip it. What is the flip of 3? 1 over 3. And the exponent is going to be the opposite sign, so it's going to be negative 4. Okay, in this example, I have 2x exponent 7 exponent 3. What you have to do is that you have to distribute the exponent 3 to every term inside. So this means that this 3 here is going to go over 2 and also over x exponent 7. So this is really 2 exponent 3, x exponent 7, exponent 3. I'm just distributing the exponent inside the bracket. Now, what is 2 exponent 3? Remember, 2 exponent 3 means 2 times 2 times 2, 3 times. What is 2 times 2 times 2? 8. Now, what is x exponent 7 exponent 3? Remember, power to power. What do you do with exponents? You multiply. So what is x exponent 3 times 7? 8x exponent 21. So that's it. Okay, now in this case, we have division of powers. The base is the same as a, so we subtract the exponents. So the result is a exponent negative 5, and we subtract, so it's going to be minus 8. Now, by definition, minus minus gives you positive. So I get plus 8. So the answer is a exponent 3. You divided 2 negative exponents and you got a positive exponent. Okay, in this example, first I will multiply all the numbers, coefficients. 2 times 4 is going to give me 8. Now, I have x squared, and also I have x cubed here. Since the bases are x, I'm going to add exponents. So I'm going to get x exponent 2 plus 3 times, I have y here, but I don't have any y here, so I'm just going to write it as y. So the answer is going to be 8x exponent 5y. That's your final answer. Okay, this example, again, like the first example, I have to distribute the power, the exponent, inside the bracket. So this 7 is going to go over negative 3, because negative 3 with the sign, okay? And also over x squared. So I'm going to get this one equal to negative 3 exponent 7 times x squared exponent 7. Now, can somebody tell me what is negative 3 exponent 7? What is negative 3 exponent 7? 2187. So it's negative 2187 times x exponent. What do you do when you have power to power? What do you do with the exponents? you multiply exponents. So 2 times 7 is going to give you 14. Okay? Now, the only question is that how can I change 14, which is positive, to a negative exponent? To change 14 to a negative exponent, I told you, you are going to flip the base and change this exponent to opposite sign. So this becomes negative 2187 times x, 1 over x, flip the base, 1 over x, exponent negative 14. Can you, excuse me, can you go and sit there, please? Yeah, I appreciate it. Thank you. Okay, for this example, I have negative outside the bracket, but everything is squared. So I'm going to expand and distribute the exponent 2 inside the bracket. This means that this 2 goes for 4 and also goes for a exponent 3. So I'm going to get, this is equal to negative, open bracket. Now, exponent 2 goes over 4, so it becomes 4 exponent 2. And a exponent 3, the whole thing exponent 2, divided by a exponent 5. Now I'm going to simplify 4 exponent 2. 4 exponent 2 is 4 times 4, which is 16. And there is a negative behind the bracket, so I get negative 16. Now, a exponent 3 exponent 2, power to power. You multiply exponents. So I'm going to have a exponent 3 times 2 divided by a exponent 5. Now, a exponent 3 times 2 is a exponent 6 divided by a exponent 5. Now, when the bases are the same and you divide powers, what do you do with exponents?
You subtract them.
You subtract them. Excellent. So you say negative 16, a exponent 6 minus 5, which is negative 16, a exponent 1. But you are not done yet, because you have to change everything to negative exponents. So to change a exponent 1, I'm going to flip the base, which is 1 over a, and make the exponent opposite sign. So I'm going to have negative 16, 1 over a, exponent negative 1. Okay, for this example, I have negative 2p squared exponent 3 times negative 3p exponent 2. Again, I'm going to distribute exponent 3 inside the bracket and exponent 2 inside the bracket. So this means this becomes negative 2 exponent 3. I'm taking the sign negative 2 to exponent 3 times p squared exponent 3. I'm distributing 3 inside the bracket. And then negative 3 exponent 2 and then p exponent 2. I'm just distributing it inside the bracket. That's all I'm doing. Now, negative 2 exponent 3, this means negative 2 times negative 2 times negative 2. If you do it on your calculator, you get negative 8. Remember, negative number exponent, odd number gives you negative. Negative number exponent, even exponent gives you positive number. P exponent 2 exponent 3, you multiply the exponents. So you get P exponent 2 times 3, which is 6. Negative 3 exponent 2 becomes negative 3 times negative 3, which is 9. And p exponent 2 is p squared. Now, I'm going to multiply like terms, negative 8 and 9. I'm going to get negative 8 times 9 is negative 72. And since the bases are the same, I'm going to add exponents. So 6 plus 2 is going to give me 8. So I get p exponent 8. Again, this guy wants negative exponents. So I'm going to flip the base, which is p, and then make the exponent opposite sign. So this becomes negative 2, 1 over p exponent negative 8. And that's the final answer. Okay, in this example, I have two brackets, 15r exponent negative 4 and 2r exponent negative 3, and I have to express the result in negative exponents. Again, I'm going to distribute the first bracket into the second one and multiply the like terms. The like term to 15 is 2, so I multiply 15 by 2. 15 times 2 is going to give me 30. Now I'm going to multiply r exponent negative 4 times r exponent negative 3. Since the bases are r, I'm going to add exponents. So it's going to be negative 4 plus negative 3. Now, 30 stays 30, but negative 4 plus negative 3 is going to give me 30 times r exponent negative 7. And that's my final answer, negative exponents.